Hey, this is my movie about the filters we were supposed to make. And first off, I would like to show you how the filters work. First off, there's the invert. Then we have threshold into binary image. We have some simple brightness, simple darkness. And then we have a simple contrast and auto contrast. We also have grayscale, exponential grayscale, and logarithmic grayscale. Yeah, and this is my histogram. As you can see, there's a lot more black in the image than any other color. And we have alpha blending. And there's the background subtraction. Which takes a snapshot of the background. Yep. And then we have mirror and flip. And then we have a blur filter, which can be increased and decreased. And then we have our Gaussian blur, which looks like this, and a Gaussian sharpen filter, a Gaussian edge detection filter, a Sobel filter, a preview filter, and then we have our median filter, and then we have to make it into a binary image again to show dilation and erosion. Besides that, then we move on to our normalized RGB, which is the middle ones here, the red one, green one, blue one. Then down here we have the pink and the orange tracking, which is made by tracking how far they are away from the perfect pink or orange color by scaling their color accordingly. And as you can see, they have a lot of gray because they're going all the way from perfect red, perfect green and perfect blue to the quarters, to the colors that they are meant to track. And as you can see, if I put in a orange can, I just have to tilt it the right way so that we can actually see that it is orange. Like this. Then you can see that it's a lot whiter down here where it's orange. You can also see that the blue up here is responding to this blue Fanta, and the red one is responding to this. You can also see that the green one is responding to the leaf, and I don't really have anything real pink, but you can see that this dark red-ish color is also responding more to the pink than the rest of the image. And that's it for how the filters work, so let's move on to the code. Yes, this is the code. We're starting with the header file, which is where we define all our variables. As you can see, we have defined a lot of arrays and textures for making new video streams. We also have all the basic that variables that come with the movie grabber example, such as cam width and cam height and the original arrays and such. Then we have a image for our alpha blending. We have some doubles and some integers and booleans and all this. And if we move on to the code, we have our setup where we define the initial value of all of our values. As you can see, I also have some center of red and green because this is also the file that I keep my tracking filters in. We then load the image in here for alpha blending, resize it, make the new arrays with the right size and allocate some space for them. Start with setting all our modifications for the filters to being false, so none of them starts by being on. Down here we have a histogram, or the array we use for the histogram, which is called red at the moment, that we set to all the values to be 0 in at the beginning of each one. Then we have some max and means, one for the auto contrast, one for the pink tracking, and one for the orange tracking. Down here we say every time the frame is new, we start running through all of our code. And here we load in the background, use the background subtraction. So when you press the activate background subtraction button, it takes a picture of the background, loads it into this array, and then it subtracts the current picture, or subtracts the background from the current picture later on in the code. We have our video where we load our set the initial value of our arrays and load the pixels into our video inverted and such. Then we have our grayscale, which we are calculating using this formula for Luma, which is the red pixel times 0.3, the green times 5.9, and the blue one times 0.11. And then we go in here and say if this modification is true, make the exponential. If this one is true, make it logarithmic. Otherwise, just make it normal grayscale. And here we have our histogram. We also have the formula for alpha blending, but it refused to work with the formula presented in the book, so I found a smarter way available in the open frameworks. And yeah, background subtraction, as I said, we subtract the background from our current image, and if it's below 0, set it to 0. Then we have our inverted, which is just 255 times current minus current pixel, of course. And then we have our mean blur, where we run through the image and start a bit in, so because you can't blur the edges as they don't have a row at the edges, basically. We then run through the colors and set the sum to 0, and then we take each of the pixels surrounding the one we are blurring and add them up. So we can take a a mean of them down here and set that to be the value in our temp array. Very important that we set it to the temp array, because if we were doing it on our original image, it would fuck up the next pixels, as they would just bloom more and more and more. Then we have our Gaussian blur with our kernel here, and then we calculate how many values there are in the kernel, what the sum of all these values in the kernel is, as we'll need that for dividing later on. Besides that, it's basically the same code as the mean blur, except that we are timing each of them, or we are multiplying each of them with the kernel value, and then again dividing them, but with the total and not just with 9 as in the mean blur, which is also the total. Then we have our Sobel vertical, which is again same as Gaussian, just with 3 instead of 5, which means that all these are starting at 1 instead of at 2. And then we also have some boundaries, as they tend to end up below 0 or above 255, and we just want those to be limited to 0 and 255. Sobel horizontal, again just change the kernel. And then we have the privet, which is the same as the above with changed kernel. Most of these neighborhood operations is just changing the kernel. Our sharpened filter, same as above with changed kernel, and the Gaussian edge, same as above, but a bit changed kernel. And the reason we aren't dividing all these with their total is that the total is either 0 or 1, so there's no point in dividing them by that. Then we have our median filter, which is slightly different, as we don't have a kernel, but we still have an array of the same size that we are loading all the nearby values into, so all the for loops are the same. And then when we've loaded in all these values, we run them through a bubble sort to make sure that we have the middle value that we then put into our temp array down here. And yeah, this, as you saw in the video earlier, is a combination of an erosion and dilation filter, which is quite neat. We then have the transform filter, which we weren't supposed to make for this one. Then we have where we calculate the min and max for our auto contrast, where we basically just say if it's listed the min auto already there, you make it the min auto, and if it's bigger than max auto, you set it to be the max auto. Then there's the mirror, where we run through the whole image and set it to be the opposite value accordingly. And same with flip, just the other way. And then we have our binary image, where we just say if it's above a total value of 382, then we set it to be 255, otherwise it's just 0. Then we have our simple contrast, where we again have some boundaries, and otherwise just say minus 65 times 2. And auto contrast, we use the mean and max values in this formula to calculate the the what the auto contrasted value would be, as we set the maximum value and set it to be 255 and the minimum value and set it to 0 and then stretch everything in between out. Then we have our normal or our normalized RGB, which we calculate like this. As we take the R value and divide it by R plus G plus B, and then we have the normalized R, except it's now a value between 0 and 1, so we have to say times 255. And it's the same code for green and blue, except it's the green value we divide by and the blue value we divide by. Now the pink and the orange tracking is a bit more tricky. As the pink, we have a perfect pink which has a value of red equal to 0.63. So you see how far the current red is away from perfect red, and how far the current blue is away from the perfect blue. And then we set it into Pythagoras læresætning, which is used to measure the distance away from this perfect. So we are measuring how far we are away. And then again we are multiplying this value by 255, but as the perfect one would be very close to 0, we are then it means that this is inverted, and therefore we have to invert it back if we want the white pixels to be the perfect ones. And it's the same for orange, except we are using green instead of blue. And that there's our erosion and dilation filters, which says if we have our binary image on, we can then turn these on, which is again pretty much the same as with the mean blur, adding up the sum and going through all these for loops. But instead of doing as we did before, we say, and here if we set on the dilation, then it says that if the sum of these are more than 0, it will be white, and if it's otherwise it will just be set to black. And in erosion it has to be totally surrounded by white to be set to white again, otherwise it will turn black. Then we have some auto contrasting for our pink and our orange, which is exactly the same as the auto contrast above, to make it more visible what is what's pink and what's very far from pink. And exactly the same for orange. And then we have our brightness and simple brightness, simple darkness. We also have a formula for a better kind of messing with brightness. So yeah, again we need some boundaries, otherwise we just add coef. And in here is where we're doing the alpha blending down here. Open frameworks have this neat function that's called off enable alpha blending, and then you just throw in the image and set the alpha blending to be 100 out of 255 for instance, and voila. And yeah, just basic drawing stuff and switch cases. There's a lot of those for these filters, and that's about it. Hope it was satisfactory.